ሰላም ተመልካቾቼ ዛሬ ደግሞ በዚህ ቪዲዮ ይዤላችሁ የቀረብኩት ፓወር ሲሪስን በተመለከተ ወይንም የዩኒት 2 worksheet ላይ ሶስተኛውን ጥያቄ ነው። Okay, number 3 it says find the domain of the function f of x. Okay, ሶስተኛ ጥያቄ ውስጥ የተለያዩ ፓወር ፋንክሽኖች ተሰጥተውናል። የእያንዳንዱን ፓወር ፋንክሽን ዶሜን እንፈልጋለን። So what is the domain of a power function የሚለውን ነገር understand ማድረግ ያስፈልጋል። So ምንድነው የምናደርገው? To find the domain of any power function we need to find the interval or the value of x in which the function converges. Okay, function converge የሚያደርግበት any values of x domain of a power function ይባላል። So let's see the a part. ወደ a part ስንመጣ we have f of x is equals to 1 minus x over 2 plus x square over 4 minus x cube over 8 and so on. ይሄ ነው ፓወር ፋንክሽናችን። ይሄንን ፓወር ፋንክሽን ኦብዘርቭ ስናደርግ we see the first term is 1, the second term is minus x over 2, the third term is x square over 4. ይሄ ፓወር ፋንክሽን ኢንፋናይት ጂኦሜትሪክ ሲሪስ ነው ማለት ነው። why? You can see that the ratio between the consecutive terms are the same. So g1 and 1 and common ratio and minus x over 2 መውሰድ እንችላለን። So this infinite geometric series converges whenever the absolute value of r is less than 1 or absolute value of minus x over 2 is less than 1. Okay, ይሄ converge እንዲያደርግ ካስፈለገ ይሄ ፓወር ፋንክሽን converge እንዲያደርግ ካስፈለገ ይሄ ኮንዲሽን መሟላት አለበት። ይሄንን ከዩኒት 1ም ማስታወስ ትችላላችሁ። So ይሄ ምን ይነግረናል? The absolute value of x less than 2 ማለት ነው። Okay, from this we can get that the absolute value of x is less than 2. This implies x is an element of minus 2 up to 2. Okay, this power series converges in this interval from minus 2 up to 2 converge ያደርጋል ማለት ነው። So በሌላ አባባል ምን ማለት ነው? The domain of the given power series is minus 2 up to 2 ማለት ነው. Therefore the domain of f is minus 2 up to 2. So this is the domain of the function in a part. ወደ b part ስንመጣ ይሄ ፓወር ፋንክሽን እዚች ጋር to the power of 2 ተደርጎ ኤዲት መደረግ ያለበት ይመስለኛል። እንዲህ ከሆነ ዶሜኑ ምን እንደሚመስል ላሳያችሁ። So if the function is f of x is equals to 1 minus x minus 4 over 2 square plus x minus 4 the whole square over 3 square minus x minus 4 the whole cube over 4 square plus and so on. Okay, ይሄንን ፓወር ሲሪስ በጀነራል ፎርም ማስቀመጥ ይቻላል። እንዴት አድርገን? if we see the patterns we can write this infinite summation like n starting from 0 to infinity alternating ስለሆነ minus 1 the power of n x minus 4 the whole n over n plus 1 the whole square ብናደርግ exactly ይሄ general term ይሄንን infinite series or ይሄንን power series ይገልጸዋል። So if this is the case we can have the summation n starting from 0 to infinity minus 1 the power of n times an where this an is x minus 4 the power of n over n plus 1 the whole square ይሆናል ማለት ነው። Okay, ይሄንን summation shortly እንደዚህ አድርገን መጻፍ እንችላለን ማለት ነው። So if this is the case now we can apply alternating series test. ሶ እሱን የምንጠቀም ከሆነ የመጀመሪያው ቼክ የምናደርገው ይሄ terms of sequence decreasing ነው ወይስ አይደለም የሚለውን ነገር ማየት ያስፈልጋል። ሶ let's see an plus 1 or the n plus 1's term. So the n plus 1's term is x minus 4 the power of n plus 1 over n plus 2 the whole square. Okay, the n plus 1's term is like this. So this is less than x minus 4 the power of n over n plus 1 the whole square. Okay, strictly less than n ነው for some fixed x. So this is exactly an. Okay, from this comparison ምን observe እናደርጋለን? The n plus 1's term is strictly less than the n's term for all n. Okay, so የመጀመሪያውን ክራይቴሪያ አሟልቷል ማለት ነው። ኦልተርኔቲንግ ሲሪስ ቴስት ላይ ሁለት ኮንዲሽን ያለው የመጀመሪያው ኮንዲሽን the n's term should be decreasing. Okay, this means the n's term is decreasing እያለን ነው። Okay, ይሄንን አሟልቷል። ሁለተኛው ኮንዲሽን the limit of the n's term as n approaches to infinity 0 መሆን አለበት። ያ ማለት the limit of x minus 4 the whole n over n plus 1 the whole square as n approaches to infinity ይሄም obviously 0 ነው የሚሆነው። so ሁለቱንም ኮንዲሽን ያሟላል። it is decreasing, the terms of the sequence are decreasing and the limit as n goes to infinity 0 ሁለቱም ኮንዲሽን ስለሚያሟላ by alternating series test the given function is convergent. F of x is convergent for every x. So if it is convergent for every x, the domain is real number እንላለን። Therefore the domain of this function is real number. Okay, አሁን የሲም ፓርት እናያለን። ሲ ጋር ስንሄድ ያለን ፋንክሽን ይሄ ነው። ኦኬ ፋንክሽናችን ይሄ ነው። የዚህን ፋንክሽን ዶሜን ለመፈለግ እንደተለመደው we take the case term or the n's term. So the case term for this power series is 1 times 3 times 5 up to 2k minus 1 over 2k minus 2 factorial times x to the power of k no. Okay, here case term ቢሆን the next term becomes the k plus 1's term becomes 1 times 3 times 5 and so on up to 2k plus 1 ነው የሚሆነው ማለት ነው over the next term that comes after 2k minus 2 is 2k. Okay, 2k factorial times x to the power of k plus 1 ይሆናል። Okay, so we have this thing. So the limit of we use ratio test, the limit of the k plus 1's term over the k's term as k approaches to infinity ምን ይሆናል የሚለውን እናያለን። So this limit is the limit of in the absolute value 1 times 3 times 5 up to 2k plus 1 over 2k factorial times x to the power of k plus 1. This is the k plus 1's term over 1 times 3 times 5 times up to 2k minus 1 over 2k minus 2 factorial times x to the power of k. Okay, we evaluate this limit as k approaches to infinity. So ይሄንን simplify ማድረግ ያስፈልጋል. Whenever you rewrite this thing, this becomes the limit of 1 times 3 times 5 times 2k plus 1 up to 2k plus 1 over 2k factorial times we take the reciprocal and we evaluate this expression. So 2k factorial over 1 times 3 times 5 times up to 2k minus 1 times x to the power of k. Okay, as k approaches to infinity. አሁን እዚህ ጋር የሚጣፋ ብዙ ነገር አለ። Okay, let's see what's going to be cancelled. All these odd numbers will be cancelled out. Okay, እየተጠፋፉ ይሄዳሉ እስከ የት ድረስ? እስከ k minus 1 ድረስ። Okay, ከዚህ ተርም በፊት የሚመጣው k minus 1 ነው። so እስከ እሱ ድረስ ይጠፋፋሉ። and እዚች ጋር ያልጻፍኩት ሌላ ነገር ምን አለ? እዚህ ጋር x the power of k plus 1 አለን። okay, ይሄንን ፓርት ስለረሳሁት እዚች ጋር እናስቀምጠዋለን። so now the simplification of this becomes ይሄ ሲምፕሊፋይ ሲደረግ የሚሰጠን ምንድነው የሚሆነው? the limit of 2k plus 1 over 2k times x as k approaches to infinity. Okay, so ይሄንንና ይሄንን simplify ማድረግ ያስፈልጋል ማለት ነው። so this limit becomes the absolute value of x. okay, አሁን limit of the k plus 1's term over the k's term as k approaches to infinity evaluate ስናደርግ absolute value of x ነው የሰጠን። this should be less than 1. okay, ይሄ c ውስጥ ያለው ፓወር ሲሪስ ኮንቨርጅ የሚያደርገው for absolute value of x less than 1. okay, so this function will be defined only on this interval. so this implies the power series or f of x converges for absolute value of x less than 1. therefore domainaችን ምን ይሆናል ማለት ነው? from -1 up to 1. okay, open interval -1 up to 1 ይሆናል ማለት ነው የዚህ function domain. okay, እዚህ ሶስተኛ ጥያቄ ውስጥ የመጨረሻው function እዚህ d ውስጥ ያለው ነው. so we will see what the domain of this function looks like. ልክ ለሲ እንደሰራ ነው the k's term እንወስዳለን. the k's term in this series is -1 the power of k times 2k factorial over 2 the power of k times x plus 3 the whole k. no, this is the k's term. okay, so the k plus 1's term becomes, or the next term becomes -1 the power of k plus 1 times 2k plus 2 factorial over 2 the power of k plus 1 times x plus 3 the whole k plus 1. okay, ak ከሆነ the k plus 1's term ይሄን ነው የሚሰጠን። so using ratio test we evaluate the limit of the k plus 1's term by the k's term as k approaches to infinity. የዚህን ሊሚት ማየት ያስፈልጋል። so this means the limit of in the absolute value -1 the power of k plus 1 times 2k plus 2 factorial over 2 the power of k plus 1 times x plus 3 the whole k plus 1. okay, ይሄ ኦቨር ስለሆነ ለማባዛት የኬዝ ተርምን ሪሲፕሮካል እንወስዳለን። that means 2 the power of k over -1 the power of k times 2k factorial times x plus 3 the whole k ይሆናል ማለት ነው as k approaches to infinity. now we will have some simplification. እዚህ ውስጥ simplification ይኖረናል። የሚጣፋውን እያጣፋን እንሄዳለን። so the simplification of all this expression becomes the limit of in the absolute value -1 times 2k plus 2 times x plus 3 over 2 as k approaches to infinity. so him further simplify ይደረጋል this becomes the limit of k plus 1 times in the absolute value x plus 3 as k approaches to infinity. By the way, this limit becomes infinity if x is different from minus 3. X minus 3 kohona infinite ayonum, but for x different from minus 3, this limit is infinite. Okay, so this tells us f of x converges only at x is equals to minus 3. Okay, so ይሄ function converge የሚያደርገው at minus 3 ብቻ ይሆናል ማለት ነው። Therefore the domain of this function is a single element which is x is equals to minus 3. so ሶስተኛው ጥያቄ ይሄን ይመስላል። ቀጣይ ጥያቄዎችን በቀጣይ ቀን የምለቅላችሁ ይሆናል። Thank you for watching.